Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation, ultimately looking for the stabilizing syllability of sensorality, showing the direct iteration of those letters into a word form that you already know, some form of essentiality, that is the most ready form of the word that you've seen. If something is essential, it is normalized, it is required, it is standardized, but it's integral. And so we've connected that logically to mathematics, reviewing, again, rederiving with new insight or added insight to some major physical laws today that everyone knows, and then more logical derivation as always. And so we've proven, derived, and established, but it already is, right? It is what it is. What is mass? It is stabilized charge. And so charging pressurizes, and tension causes pressure. And so last time we revisited force equals mass times acceleration, and now we know, and we've provided a lot of bounds and understanding of what mass is physically, literally. And so we related that, saying a force, right, it's trying to reduce something past what is logically applicable, right? Pressure is force per unit area, and pressure is the correct thing to use for logical completion. And so we discussed acceleration and a couple different things. Again, logically, right? Acceleration will be used for both increasing speed and decreasing speed, as well as technically acceleration, and then logically, people will say naturally deceleration. But in physics class, acceleration is any change of velocity. And so the big kind of things that we derived is what is mass and what is velocity. Because then you get momentum, mass times velocity. And as you can see, structured, again, velocity, power is energy velocity. But velocity versus speed is this another differentiation where how do you have any rate of change without displacement? To me, it just makes no logical sense. But again, it's just another one of these things where it's applicable in certain contexts, right? Light is radiation. Sometimes you say light, sometimes you say radiation, so on and so forth. And so for acceleration, that's another one of those words. Force is definitely the correct thing to do, is it always encapsulate that with surface area, pressure, mass is stabilized charge. Acceleration, right? Exponentiation accelerates, right? Intuitively, and again, now it's very clear that we're driving physics to logic and showing that completion, where basically everything you've seen as theory or mathematics is derivative. And so going directly from physics to logical completion. But acceleration, again, logically, the intuitive use, and again, that's where it's natural, you see its natural definition, is the natural context it's used in. And so if someone's accelerating, you're thinking getting faster and getting faster more rapidly. And currently, rigorously defined, it's just a change of velocity. But acceleration is really to exponentiation, mass is stabilized charge, and force is conceptualized with surface area as pressure. Which brings us to the most classic, it's like the denoob of physics. PV equals nRT. I don't even know what law that's really establishing or what it's called, but pressure times volume, right? Pressure is inversely proportional to volume. PV equals N, the number of moles. Again, Avogadro's number is this local limit number thing. R, that's our dynamic limit, and T is temperature. The fundamental properties being related: pressure, volume, and temperature. And so just again, kind of revisiting here, again, that's where you see thermodynamics, but we've already derived thermodynamics, right? Mass is stabilized charge. I'm an object that has mass, talking about stabilized charge, right? It's the universe discovering itself. But point being is, what can we say? Can we say, again, we're not saying anything new, so to speak. So once you get to numerical calculations, the equations are the result. But we've just added new insight to pressure and temperature, really, right? Nobody has articulated the reason an object has temperature is because of mass gap, right? That's why you have an internal temperature. So that's never been, temperature's been understood, but no one's explicitly said that, and it's truly a trivial physical proof of the millennium problem. It just is. But luckily we're continuing on with fraud, racketeering, and conspiracy, and you can't claim prizes. Again, the requirements for those is to post solutions for 2 years, and again, we're so far past that, but it continues to be a complete destruction of my life. And so, in addition to PV equals nRT, right, thermodynamics is also where you get introduced really to a formalization. And again, a lot of times people say formalization for equation. Formalization to me is just, again, any sort of logical structure. We're way past just equating things, right? That's dimensional analysis is derivative of dimensionless analysis. And so we can show this completeness at the level of language, which doesn't need a unit. And so you also get, again, an equation for entropy. But logically and conceptually, it should fit very naturally that entropy is the inverse of energy, right? Energy, the capacity to do work. You wake up in the morning, you say, I have a lot of energy today. What did you state logically? Well, I'm ready to go do things. I can get a lot of work done. And so that's energy's natural definition. And then you say, what's the inverse of that? And then logically, we'll even get to the logical difference between inverse and opposition is, again, another one of these things that has never been identified properly. But all the times you say we have an inverse. But energy and entropy are logical physical inverses, right? Energy, the capacity to do work. Entropy, disorder. Energy that cannot be used for work. So you have a very clean, again, these are physical definitions. In the same way that power is energy velocity. And so, really, again, velocity being the word that's just like clearly in that, based on it, C, velocity, that sound being iterated with the C. You can see that word form pretty striking now. But we have, again, if you see the Boltzmann constant, right, that's the dynamic limit, the natural logarithm of all microstates, right? So they've kind of equated entropy to like what I would call like elementality, just again, the up, down, the configurations is the operative word of the different particles, of electrons. And so, but we've derived conceptually that energy and entropy are inverses physically, which is a huge, massive, tremendous, mythical result. But again, it's a functional step. And so like all of I didn't even like really explain, it speaks for itself. Like people, once you think about it, like, yeah, that definitely is the right answer. But it's just a line item. It's like, okay, here's how the things work. Now you have to do the analysis. And so when people look back that have encountered me throughout my educational career, I mean, you see, again, this is a derivation that I've demonstrated, again, over we're on year 7. And like each chunk is its whole thing. So you say to somebody, hey, I'm going to derive all of this. There's no, they would have like discounted you time and time ago, but this is what it is. Thank you for ruining my life. That's really appreciated. But again, defining entropy with, you get some, it's literally Boltzmann constant times the natural log of, so it's kind of interesting why there's a logarithm in there, but again, it's just some sort of, again, this dissipation. Exponentiation is growing really fast. Dissipation is like the opposite of, you localize a bunch of things, you create a tense system, a battery, you can diffuse charge and power something, and that diffusion is kind of, I would assume, is like the opposite of exponentiation. I don't know if that's right, but moving along, energy and entropy are physical inverses, and that's the equation for entropy right now is just not encompassing whatsoever. But tension causes pressure, pressure is tense, exponentiation accelerates. Memorality, memorandum. Momentum, memorandum. What is number to momentum? Again, relating the throughout the word. Number to momentum, right? I don't know. Posing a question to get your intuition and connecting the of number and momentum. A memorandum is random. So logically, you're like, how does that? Doesn't need to make sense. It's general to, again, a point where it's not specific enough to be operative, to be meaningful. And so memorandum, again, literally preserving the phonetic memorandum, is random. Physicist is triple is, right? Physicist. So you get 3 is in physicist. What's a physicist to a mathematician, right? Mathematics, again, all of these kind of questions, it's just because all of this logic is still contained within these letters. We're just trying to find the right question to ask still. But so, like I said, we're now in these more emergent domains where we're asking what is a physicist to a mathematician, and we don't even mean it logically. We're just lining up these different syllables and showing how the syllability differentiated. And so a physicist to a mathematician doesn't really matter. It's to get the syllability and the intuition in your mind. But right, they're both analytical. Right? What is science? Right? Science is sentience, but it's using your interaction, your sensation with the world to be more efficient, to get more work done, to limit entropy, to limit disorder. And so they're both analytical. It doesn't really matter. Sensorality, or again, like I said, when we demonstrate this completeness, right, we're trying to find the right question that can be answered. You can say a mathematician, someone that goes to Harvard, or a mathematician, somebody that writes a proof, or someone that reads history. You can keep going on with things, but none of them are definite. We are showing this definitiveness with the letters themselves. And so we continue on. Sensorality is physicistality. Sensorality is systality. Right, cyst, C-I-S-T, is how I spelled it in my notebook, but also C-Y-S-T, like a cyst. Sensorality is assistality. Assistance helps. Assistancy, consistency. Sensorality is consistency. So now again, we can see this, like all of these different words with like sistency, consistency, what's sistency? And so this contraction, right? A lot of times these words, you'll see this contraction, you'll be confused. Do I put a hyphen here or not? And so all of the words that it's like, you should put a hyphen, it gets contracted, and that's why you just have consistency. Whereas if you have out of the box, you'd put hyphens between those, but it's not like, you're not combining the words. But again, we've derived the presence of hyphenation throughout language. A logical result, obviously profoundly past anything anybody else could do, or any mathematical, again, logical structure present to be able to do this derivation has not been identified by anybody. Why do people say run the numbers? Right? If you're going to do a calculation, I'm going to run the numbers. Do numbers run? And what is the analogy? Again, conceptualization is consistent. Why does that phrasing exist? And I would say this is the biggest difference within logic that has not been identified, right? You'll say, what is differentiality to inversion? Right? There's a clear difference between opposition and inversion. Right? Difference, opposite, inversion. Kind of all different doesn't necessarily mean opposite. Opposite is like maximally different. But differentiation opposes. And so the foundation, right, we have ing. You can't even identify an object without saying thing. It's the most general form, and if you want to relate it to other things logically, you use it. That's why it is what it is the form of all resolutions. And so, but opposition and inversion are different logically. And so we have physically one thing, vibration, and that differentiates. So the differentiation is chronologically the correct word. And then you have that differentiation creates opposition, because that's all you can have. You can have one thing and then one not that thing. And then you have stability. So that's where you get your fundamental stability of two. Physically, that is charge, that is what everything, those are the words you would describe everything around you with. You can't say anything else, you can try to, but it's wrong. And like physically, you can't. You can literally say, no, it's not charge. Okay, what is it? Well, it's... Go ahead. But point being is you have thing, differentiation. That differentiation produces opposition. That opposition stabilizes, so then you have inversion. So you have thing, differentiation, opposition exists because of stabilization, and then not that thing again, but it's the same, right? What's the natural, again, opposite of that now? Right? You don't really have one. And so that's where you get numerically, right, there's a well-defined center point between odd numbers. And so point being is inversion to opposition. Now again, that's physically. I have to use words to introduce that intuition, but that's a physical differentiation. And so now in mathematics class, right, you have, if you take the inverse of something, like that's verbiage you use, and you've never seen that chronological differentiation, but that's why you say you have an inverse of something. 1 over x, x over 1, those are inverses. Right? Inverses produces reciprocity. And so what you do for me, I do for you is reciprocal. But if you oppose something, you don't reciprocate it. You separate it. It's different. And so you don't have, right, reciprocality is not, if you oppose something, you do not reciprocate it. So reciprocation comes from this like stabilized opposition, but that's only after the physical stability. And so, right, because you don't have, right, you don't take the opposite of a number. You take the inverse of a number or the inverse of a function. And so that comes from the bounding. And so again, the physical, there is no stability of R3. So there's no physical, because I have to say the inverse of logically of everything is nothing, but physically that pairs to logical inference before stuff existed. And so, because if you notice what happened there is I had to use the word inverse for opposition. And so it's like, it's the most nuanced progression of logic that I've come across. But again, nothing is complicated. It's just, there's no words to use to describe these things because you have to try to use words to force intuition. But there's a clear, like, logical, physical boundary. And I walked you to that as bit close to as I can. Point being is there's a reason you don't say 1 over x is the opposition of x. And it's the reason I just walked you through, and there's nothing else you can say about it. But that's true. If there's more insight, I'll try to. But opposition separates. And so you can see it kind of linguistically in the word, right? If you have a site, that's a position, that's a location. And then you have an opposite, right? You have one thing located somewhere logically, and then it's opposite of that. That's stability. And then you have inversion, where it's like, 1 over this, x over this. And then that kind of messing that up is where you get, infinity's undefined, or you can't have 1 over 0. It's like 0 can't represent anything. They're bounded sets. 0 uniquely represents nothing. Infinity is a mathematical concept that has inversion, infinitesimality. That's what you're doing with an infinitesimal. Infinity is not a physical boundary anywhere, but it is a well-defined mathematical concept. And so physical stability provides inversion, but what happened first was most logically akin to opposition, right? Positive, negative charge, bounded. And then that thing tries to oppose itself, and then you get proton and electron. But if I can say anything more there, or if anything, again, anything that's directly physically wrong will be immediately apparent. But this is a logical differentiation, and you clearly don't say, right, 1 over x is the opposite of x. It's the inverse of x. And that's really why, because you're in this environment with bounding. And so it's also where you can't divide by 0. It's not a valid mathematical representation. And that's also the inverse of infinity. When somebody comments on there, oh, it's undefined. It's not undefined. There's a ratio how fast information can travel, and then there's a limit how slow information can travel, because everything's moving. And so that was a good little section there, moving along. But inversion is bounded. Consolidation normalizes. Right? Consolidate, console. Interaction normalizes. Exchanging consolidates. Right? We showed that change and charge are related by the geometric relation of R to N, and charge is set. It's this inherent stabilized property of mass. It is mass. And so charge does not change. And then we have this word exchange, right? For every action, there's an equal and opposite reaction. A reaction or an action is an exchange of information. It's an interaction, right? And so we have this logical bounding, again, of this sensorality with a C, sensorality with an S, and speciality. Right? That's kind of our bounded opposition, is speciality and sensorality being our opposites, and then sensorality with a C kind of being this inverse of sensorality with an S. And so, yeah. But what has changed to exchange, right? If you exchange something, in the physical intuition I got that question from, is if something can't change, you exchange it, right? Charge is exchanged. It can't be broken down anymore. Mass can't be broken down anymore with a physical limit. That's just stating the conservation of mass. And all right, so change is to something that is variable. Exchange is to something that's invariable. It's irreducible, so you have to exchange the whole package. That's kind of the intuition that question came from. Additionally, what is continuity to consistency? Right? Continuity is synchronization between independent objects, and consistency is, right, if I have a block of iron, that's consistent. Physical consistency, it's the same thing. And so continuity connects independent systems, and consistency is to internally of one system. And so I think I did a good job of explaining this opposition versus inversion. Again, a logical differentiation that's clear as day, and nobody has ever identified it, talked about it, and it's an analytical step. So this is where I'm seeing it's not fun to be more developed mathematically, to the point where it's like identifying these things as Fields medals on Fields medals on Fields medals, and people are so entrenched with that shit, you can't even begin to do research, because it's just people have such, again, ontological shock is what you call it, but it's delusion. It's the Dunning-Kruger effect. They're the stupid person. They destroy your reputation. They have no ability to sit down, shut the fuck up, and listen. I can explain it all. I can very literally prove anything to anybody if they just listen. Have I ever been in a position where I've been respected or listened to? Truly ever. It's not some sort of emotional, personal statement. No. Ever. Just at any point in time. But I think I explained it pretty well. I'm not going to rederive it right now. But again, I'm deriving these things. And so even if I were to say something exactly and precisely wrong, it's the intuition, it's the identification of fundamental differentiation, which is what is most poignant with language. I can see it's immediate with anybody all of the time, and then there's inherent consistency, what words relate to certain words, and that's the point where it's just off the charts, never remotely been seen before, where it's trivial to derive and prove anything to anybody with anybody's. They start saying something, somebody else over here, I can connect the entire logical structure profoundly trivially. But that is why you say inverse in math class and not opposition, is because we have this physical bounding that provides inversality, or the ability to invert something. So that is what I have for you today. Thank you for watching, and I will see you on the next one.